Here he comes. Here he comes. Yay! Give it all to Michael. Woo! Does he need some introduction?
I need a clicker.
You need a clicker.
Yeah.
Here.
Oh.
Will it work? No? Give
will not-
away.
How can? Okay, I don't need a clicker.
Okay, then.
Okay,
Are you?
welcome to my introduction-less talk. No, just kidding. Welcome to my talk on incremental hydration. Before I start, I want to plug in the cable so that the beamer is working, and then we can kick it off. You're wonderful. Okay. Incremental hydration in Angular. It is a pretty new fancy feature. I'm very excited to talk about that. It's in pre-release state, so there might be some changes. Most of the things that I show you will stay as they are, especially the new mini libs that we moved in. I will show you that later. But maybe some small internal changes will arrive. Quick overview, what do I want to talk about? Hydration and a breakdown of it so that we can understand it a little bit more easy, that we have our categories, our sections in that process. Then I want to talk about the impact of incremental hydration. Why do we do that? Who's caring about that stuff? And then we will go really deep. I really want to talk about all the core parts of it, event replay and recording, the component state, and in the end, I also want to show some hydration pattern and a little bit of a live demo. I grab some water here while I'm waiting until the page is loading. Okay, so what we do is when we load a page, we normally wait until we finally see something, and then we will click it, and then we will wait until something is happening. And the longer those processes take, the more annoyed your users will get. And I believe it is really annoyed, not any other word, maybe frustrated, right? And I want to show you a little bit how I feel when I wait for something, because I guess I'm a very good case of being impatient, an impatient person, right? If I click somewhere, I really immediately want to see it. So I click here on a button and I'm excited to see something, right? I'm like, yeah, what will I see next? And then I wait, and then I'm like, okay, if it doesn't show up in a second, I go for a coffee. And I still wait for that, and 200 more milliseconds pass, and my brain is already going crazy. Like, why is it taking so long? I cannot take that anymore. And finally, in the end, when my page shows the image that I really wanted to consume, I'm already in rage mode, right? I don't care about the website anymore. I will leave, I will close it. I will never, ever come back again. That's it, your fault. So, what does that mean? Unhappy users means you will lose money, you will lose traffic, you will definitely lose. And that's a fact. People try to calculate that and say, look, if Amazon has 30 milliseconds, more or less, they make this and that more money. I guess that is how we started to explain why performance or why loading speed matters. Nowadays, I guess everyone agrees that if you're pissed about the loading time, most probably you just don't use it and then you lose it. So let me help you to fix that. My name is Michael. I work for Push-Based. I do a couple of different things. First here is architecting scalable Angular apps at large scale. And in this talk here, I also focus a lot on performance. We are also proud maintainer of the official NX workshop. I can only brag about that because I'm so proud of it. And that was the intro. And let's go back to to the Angular part. And just that we get a little bit of a clue where we were coming from, I want to talk 2 slides about reboot versus hydration to link from the past to the today's situation. And this is what we had. We had a website that took a little bit to load. After that, I was already gone, but other people stayed and waited for loading. And then I had a first paint, the server-side rendered part of Angular, and it showed something, something that looked pretty good. There were already some buttons and things on it, so server-side rendering itself worked, but then something weird happened. The page fully disappeared and got redrawn from the very beginning. And that's what I call rebooting an application. It has nothing to do with destructive, non-destructive hydration. There was no hydration, right? 0. Therefore, I use reboot. So we rebooted in the past our application. We deleted the whole DOM, and then we recreated everything from scratch. We did not reuse any part of the DOM. So therefore, no destructive hydration, just reboot. Nowadays, we have hydration. And what hydration does is it keeps the DOM nodes in the browser and it crawls through it, understands where they start, what listeners, what parts of Angular they should get connected with. And then the Angular app bootstraps again. And you see there is no interruption, there is no white screen in the middle. Everything renders smoothly and it renders way, way faster, because we don't have to like delete and redraw something. That's just a quick recap. And now I want to straight away go to incremental hydration. That is the latest and coolest feature on hydration in Angular. And of course, we can start on how we configure that. And in our app configuration, we have the providers array, and in the providers array, we can provide client hydration with that function here. And then you can add with event replay, and you would already be able to capture a little bit of those events. And in the latest version, you can also add with incremental hydration. And if you use with incremental hydration, you actually don't need with event replay anymore, like you don't need to import it anymore. It is automatically imported. So that's how you configure it, and that was pretty easy. What's not so easy is to understand what is going on in the background. So I made a little bit of a breakdown, I call it hydration breakdown, to elaborate what parts, what phases are involved. The first phase happens not on the browser. Happens not on the browser. And the first thing is that we have a little bit of a different build step. Then we consume that bundle in our Node application. We create some HTML string and then we send that HTML string to our client. And that can be done in a couple of different ways. You could also hook some fancy streaming things in between, what we do when we optimize applications. But in the end, those are the 3 steps. You want to build that, render it somewhere, and then take that rendered HTML and ship it the fastest way to the client. When it enters the client, it's all about displaying that stuff. So you will have to parse the received HTML in your browser. And then the browser needs to render your DOM nodes and need to paint them, right? Rendering layout of your DOM nodes and painting. And when this is done, or in parallel while this is done, you also load the application code. You load all the JavaScript and all the other missing styles that you would need for the full application to work onto your client. If this is done, the app did not fully bootstrap everything. You can consider there is an initial phase where you hydrate everything that is not flagged with an incremental hydration. You have the event replay logic in there in that phase. And then, since the latest release, you also have the incremental hydration of the application. So later on in time, when the app is already bootstrap loaded and so on, you still can click on parts of unhydrated parts of the application. It will still do the event replay. It will still hydrate your application. Okay. Let me give you a little bit of a more details of all the steps, and let me highlight what the latest features are in all those steps. In the build and transfer thing, I told you already, you have to build the application, you have to server-side render the application. And when you server-side render the application, you also want to understand what state do my components have. So you need to like inline your component state somewhere in the HTML, and then you need to link this JSON object that maintains the component state somehow with your DOM. Also, you need to understand where the event listeners are, and you need to link them somehow to the DOM. Then you transfer that to the client. You can, as I mentioned, use different ways of doing that, but there was nothing really new. In the render phase, HTML parsing already existed, okay, but on the client rendering part, there is another part that is now pretty interesting or pretty important. That is the event record and replay. So whenever we interact with our page, which is not hydrated, you might lose interactions when you don't record them with a special technique. This is done here with JS Actions, and I will show you later on the library where it's coming from and what it does really. But that's, I would say, the interesting part of that area. And then we have also resource loading and that delay. Good. That was all the rendering part. Now we come to the hydration part, and I mentioned already there is the initial hydration that takes all the DOM that is not flagged with any defer and hydrate marker, and it will take over the DOM, it will wire all the global event listeners, and it will replay any previous interactions on your client. And then you can go and then you can try to navigate through your page. And maybe some parts of your page are not yet already hydrated, dehydrate incrementally. Then you again would want to record and replay interactions on the unhydrated things in your application. So that was the hydration. That was the hydration breakdown. And now I want to talk a little bit about all the different blocks. First, I want to highlight the beautiful release strategy. I'm not sure if you follow like which features are shipped, and maybe you kind of guesstimate what will happen next 6 months, next 1.5 years. It's really nice to watch, and I believe it's a beautiful pattern, like in the order and they release the features is really wonderful, especially the last two ones. And here I want to obviously highlight V19 with the incremental hydration feature. So that's pretty cool if you also try to like understand how a team rolls out bigger features over time. That's a beauty. I keep that for a second. Maybe someone wants to make a picture. Use that second to grab another sip of water, and then I go on. Perfect. Okay, so why do we even use incremental hydration and all that stuff? There must be a benefit. And maybe you already know that it will increase the loading time, and it will also improve the responsiveness of your page. But you maybe over or underestimate the impact of it. So what I do, or what our whole company's mantra is don't guess, measure. But you know how it goes as a developer. Sometimes you just don't measure, you guess. It happens regularly to me, so I want to use that time here to re-emphasize what areas incremental hydration will mainly impact. Obviously, the third core web vital here, cumulative layout shifts, is also impacted, but those two are for me the main areas of impact. Incremental hydration will impact the largest contentful paint, and it will impact the interaction to next paint. And those two metrics I want to quickly show you where they are connected to the process. So the LCP impact of your server-side rendered application and then incrementally hydrated application is in those two phases. And if you recall quickly what LCP does, it's fine. If not, I repeat it for you. You have at the very left of the chart here, on the very right for your vision, the loading event. You wait for some data to transfer that, so you have the symbols that I used before in the breakdown also here. And then you need to process all the HTML, and then you need to load that. And during that loading time, you might have different LCP candidates, right? Maybe first the headline pops up of your page, and that is definitely the LCP candidate at that moment in time, but later on also the images load in, and after the first image pops in, that is most probably your new LCP candidate. When you're done with rendering and frame presenting, then you know which of all those candidates is the last one, is the most important one for you, and that is then the LCP element, and with this candidate you can also determine the LCP time. The second metrics that I want to quickly scratch here is INP, interaction to next paint. It's a wonderful new core web vital. It is way more accurate than my previous vital, total blocking time. That's what we used to somehow prove that the page is interactive. Now we have a real specialized metrics that only focuses on user experience when they interact, not when the browser is doing some other scripting, and that's pretty beautiful. So I wanna quickly also walk through those parts here. And interaction to next paint obviously starts with an interaction. So I click somewhere. Let's say I click on a button that navigates to the movie detail in our Movies app. And the first click of navigate to that page would be my interaction. And you already see the first section here, input delay. It could happen that while I click that button, the browser is heavily calculating something very, very important. And maybe where the ad banner is placed, right? Something really, really important. And you click exactly at that moment. Then your browser will not be able to process the click immediately. You have to wait until the previous task is done, and then the browser can process your click. So you might experience an input delay. But when the input delay is done and the browser really is able to process your click, okay, then you are in the processing phase. The browser fires the event, happily processes your click handler, and then in many occasions the browser also changes something in your DOM, and then it has to render and paint that change. And when this is done, at some point, maybe the browser presents the new frame to you. You see all the different pixels in new colors. And that's the end of the interaction to next paint metrics. And as this is not a single interaction that you measure, but multiple, I also want to tell you that those processes that I explained now run constantly on your website, and the output, or let's say the result of that stuff, is aggregated together to one number. You will take always the worst LCP interaction that you had in your page, and then you wait for the next interaction, If there is an even worse one, you will take the next one, like always take the worst interaction of all, and then you drop every fifth of it to also reduce the chances that you have a couple of outliers in there. And that's then your INP metric. That is how you can understand it. So now that we know that, we can go on and we can really deep dive into the hydration part. And there are two key things that I can elaborate here. One is the event replay part, and one is the hydration part. So let's start with the event replay part, and let's talk a little bit about JS Action. How many of you ever heard JS Action here? No one. It's really cool. It's your talk. You learn something. Now I will surprise you. How many of you ever used directly or indirectly JS Action? Hands up. One hand. Let me ask a different question. How many of you ever Googled in the Google search? Aha. So, Angular is a framework made by Google that everyone knows because it is a public framework. This is a framework made by Google that no one knows because it is an internal framework. And this internal framework is pretty fancy. It is made for heavily performant pages. Pages that need to be so fast that users are surprised how fast they are. So that they can scale, so that they can serve us a really good experience when we, for example, use the Google search bar here. And as no one raised their hand, maybe you will question my seriousness here, and you will say in your head, is Michael really correct? Do we really use that? And I can try to prove that for you. I can open up a new page, and I can go here in my Elements view, and let me zoom in here a little bit for you. Is this possible? Can I zoom? Yeah, wonderful. Okay, that was a lot of zooming. Let me try to reorganize. Yeah, okay. Where is it? Somewhere here. Let me search JS Action. Here we go. There's one tag already, but on the search input here, there is another one. And if I would make a recording, I would also be able to show you the event replay part that is working within the Google search. So that part here, just that you really believe me, is proving that Google is using this event replay feature, and this event replay feature is now also inside Angular. Here another screenshot. You know, sometimes I'm not able to find characters between all other characters, and then I make a screenshot of it so that I cannot miss it, but that's the proof. So all of you already used JS Action, good that we agreed on that, and all of you maybe are now very curious what it really does and how event replay works. And I can help you with that because I have a mini chapter about event, record, and replay. Oh, the formatting is broken a little bit, I see. It's sad, but it's okay. The first part of the event replay is you need to load the JavaScript. You need to load the JavaScript that you can execute it, and then after this tiny bit of JavaScript is loaded, and I can show you later on the script if you like, you can start to record user interactions. And that is done in a pretty nice way that I can show you later on. And when you record all the interactions, at some point your app wants to hydrate, and then it needs to load JavaScript, and then it needs to compile JavaScript, and then it needs to execute JavaScript. And that maybe takes some time. Normally that takes quite some time, depending on the size of your bundles. And after that is finally done, you already missed all the user input, right? The user typed in the search, in the Google search something. And then you wait for all of that, and then you hydrate, and then all the typing events are gone. But not with JS Actions. With Event Replay, you can replay that events. You can say, okay, I want to listen to all events on this and that specific component, the search box, for example. Then I let it hydrate on the first interaction. Maybe I hydrate the component, or even earlier. And when I'm done with hydration, I replay the events on that DOM, on that part of the application, and it will receive all the interactions in the right order and then render based on my interactions. So the first step of this whole JS action thing is the event recording. And if you look at this part, maybe it's familiar for you. You have on the left side an attribute and on the right side a value. You have a click event, you have the event name, and then you have a callback on the other side. As this needs JavaScript, that might not work super well, so let's try how JS Action is doing that. You also have a attribute on the left, and then instead of a callback handler on the right, you just have a string. You have a string that tells you which event you want to care about and the handler name. And the handler name is a little bit interesting because you only would need that in Wiz, because Wiz is way more fine-grained than Angular in the features, and Wiz can load event handlers. Actually, Wiz is doing exactly the same as Quick is doing nowadays. It just did it a couple of decades before or years. And Quick is a derivation of that whole idea, I would say. But in Angular, we don't need it. We don't load event handlers, we load components. That's our most fine-grained unit. And so we don't need the handler name at all. And it just looks like this, where you have the event name, colon, semicolon, event name, colon, semicolon. Like this. So that is what you will see in your Angular code base. Good. A lot of big characters. Let's make smaller characters now and more images. I have my Node app or my Hono app or my whatever I want to use to render Angular. It gets more and more decoupled from the old way where we used Express. And when I render it, while I do that, I inline a small script, JS actions, into my HTML at the very top. And this script is blocking, so the page will not do anything else before I execute that script. And the script is very, very small. It's like a couple of lines of code that quickly execute. And what it does is it records, it adds a couple of things to the DOM, and then it starts the recording. So what does it add to the DOM? It adds all these JS action markers that I showed you before to all event bindings inside Angular. That happens already in the HTML that is then shipped to the client. Then it does something else when the script executes on your client side. It will add one single event listener to your body, and this event listener will listen to all the events that bubble up from your application. You know, like events bubble through the DOM structure. And imagine you have this like unhydrated button with the JS action marker, and you would click it. Even if there is no real event listener, you clicked it, the click event is fired on the DOM node and will bubble up the DOM tree, and at some point will reach the body. And there is your JS action listener listening to the click, and then it will receive that click and will say, that click is coming from a button with this JS action marker attribute. I know what to do with it. I just will store the element name and the event name in my array. So I see that marker, I detect it in the global listener, and I add the interaction to my store. We use ngrx store here, not just kidding. And I have that in the queue, and I can show you how that looks in real life by just navigating. Where do I navigate, by the way? By navigating to my code base. I guess that's a good start. And then I check out what is happening here. Is it running? Is it not running? Okay, it's not running. Good. I rebuilt that. I copy the URL, go here, put it somewhere. And then I click on server-side rendering, and then I turn off my JavaScript, and then we see ears. And then we see ears on all the DOM nodes that have this JS action marker on it. And when I turn on my JavaScript again, let me quickly navigate to a page that is not fully server-side rendered. And if I would turn on my JavaScript, you will see some of the ears disappear. So the ears on the very right side for the menu disappeared because that part of the page already hydrated. The ears here didn't disappear because that button here is not hydrated yet. It's an unhydrated DOM node. And I could click that, and the ears disappear. I clicked on the wrong part. So the problem with the ears is I sometimes click on the ears and not on the button. Let me refresh, so otherwise you don't believe me. Now I click really on the button. You saw? It works. Just don't click on ears. Yeah, but ears disappear and then get recorded and replayed, and you saw the slider moved, the toggle button toggled. Perfect. Where do we go back here? Good. Let's check the time. Okay, let's speed up. I have time? And I have time. Good, then I don't speed up. Let me have another sip of water. And then we talk about state hydration. Yeah, hydration is very important. So, a lot of different characters and colors. I'm overwhelmed. What is it? At the bottom of your server-side rendered page, Angular application, you have a script. That script has an ID and it's marked with ng-state, just that you know it belongs to Angular and not to Viz. It's a JSON object that you ship, and in the JSON object you have a lot of information that is heavily obfuscated. You cannot really read that, but I kind of explain what it does. Okay, so you have a couple of keys in. You have the first one here, ngh data. Ngh means ng hydration, most probably. I don't know, I never asked someone, but I believe ngh means ng hydration. Then you have the hydration data, then you have the deferred data a little bit below, and in those two slots you store states that you want to add to your components. You store the states that you use for initial hydration, and you store the states that you need for incremental hydration. And it's a key value pair out of weird characters and strings, but what they should really do is they should link to, on the left side, your component. So I unminified the object, and on the left side is the component name that you use, for example, the dark mode toggle or the toggle of your theming. And on the right side, you have the state of the application. And here in my example, the movies app is on light theme normally by default, so or dark, however you choose, but it has some state. So that is stored here. That does not live in your Angular application so far, and when you hydrate, you take that state, apply it to your component, and then you replay. And yeah, that's how it looks. You can open up your Angular app and check it. As I have a lot of time, I heard. I can do that on my own. Not what you said, okay. Where is my Elements tab? Here we go. I go to the bottom, I have this script, and here the truth, it is a very hard to understand JSON structure. I told you, but just to reassure you, you can believe me when I say something. Good. Now that we gain a little bit more trust in my presentation, another screenshot, how it looks. And let's go to the next step. On every so we have this JSON object at the bottom, right, in the script tag, and now we know, okay, there is a component name and blah and this. In fact, it's not a component name, it's an ID. So I lied to you, I'm sorry. It's an ID, and every component has that attribute, and I call that marker, has that hydration marker on it, and this hydration marker just knows which ID that component has. And then it can go down to this weird JSON structure, map the ID with the component name, takes the state, and does something with it. What does it do? It renders, it adds this script at the bottom, and everything is asleep, everything is unhydrated at the moment. And then when someone interacts with this component, with the marker, I can link that component with my hydration state, and I know where it belongs to, which component needs which data. I showed that to you already, so I won't open up the page again. I get evil views here from the front row. And I will talk about event replay as the last part of these steps. So let's click on the next slide. And I start with my global recorded events. I typed on the buttons and I stored that somewhere. And I forward those events on the event, on the DOM that was flagged with those events. And then I will replay that. There is a broken state. No. And then I will replay that. And I can show you a little bit more demos on it. I will click that. I can go to, again, server side, and I turn on my hydration. I can go to my code, and I can try to add that stuff around the whole side menu. So let's start here. Let's do on interaction. And let's scroll down. And I hope it will work. If not, I have a fallback demo. Don't worry. I miss an I. You are correct. And I also miss a closing bracket, by the way. By the way. If we are correcting typos, let's do the second two, okay? I still a typo. Interaction. I told you, live demos is hard. And now I refresh, I turn on the JavaScript, and now we see the ears remain on the left side. So all those unhydrated parts have listeners. I can click any one of them, click, and I navigate to another page, and I hydrate the component thing. That is really cool, and a quick demo that it is really working. And I can go back and go to the last part of this, this presentation, because time is over. And I can show you that you can add a defer block, you add hydrate at the beginning. Be careful, you can make typos, as you saw. It was obviously part of the real demo. And then you have different triggers. You can trigger it on idle when the browser is done with fetching everything. You can do it on interaction, or you can do it never. That's also pretty cool. And if you have a very static page, you don't need to hydrate, right? The Movies app, for example, could live nearly without hydration. You can do that with different patterns. We also add specific tricks, right? We say, do it on interaction, but already prefetch the data for the stuff you load. That is, I believe, something that you should also think about. It really improves the whole situation quite a bit. And now I finally can give you the last demo of the day, where I show you how it works incrementally. So let me full screen that and go to the on interaction. So I turn off JavaScript, and you see, when I refresh that, that everything has ears, and we have these sleeping phases. And if you remember, sleeping phase is unhydrated component state. I turn on my JavaScript, parts of the ears disappeared, so full hydration kicked in. And this part here is the first bit where we incrementally hydrate and where we have real state. So I hope that it works. When I click that heart button here, I will send this stuff to the server, mark it as my private highlighted movie, and then update the component state and load everything. And if I click it, let's hope it works. Yeah, if I click it, the heart turns red. So that means I incrementally hydrated a part, triggered all the other stuff afterwards, and it's still working. And if you would not have seen the sleeping icons, I believe you would not even have recognized it. So that's pretty cool. You can obviously do that with more realistic applications too. Then I would suggest that you preload the JavaScript. But you saw it is working, and I can finish off my presentation with re-showing this wonderful graphic. Maybe I liked it so much that I show it 3 times. I also want to give you a reminder that if you optimize your page, it's also data efficient and green. The earth will love you. And that's it. I hope you had a little bit of fun and you learned a lot. Now you know that you use JS Actions already all your life. Be happy about that new learning, and see you later. Bye.